and welcome to CA1 Flexible Storage Upgrade and Enablement. My name is Russell Witt. The agenda we'll follow today is about upgrading from CA1 Release 14.0, and it doesn't matter if you're at 14.0 or 14.0.01. Then the pre-req requirements if you want to enable the new flexible storage, the new tape encryption. How to set up for the new tape encryption database, control statements, how to activate it, commands you can enter, and some best practices. And finally, a few minutes on debugging. So, upgrading from CA1 14.0 couldn't be simpler. Modify your dynamic link list to include the new 15.0 CTAP link, or replace the contents of your existing library with the new library. However, note, the new CTAP link library is larger than the one in 14.0, so you might run into a space issue if you do not have secondary allocations defined, and for linked list libraries, a lot of sites don't. So it might be easier to simply, if you're using a dynamic link list, include the new 15.0 CTAP link ahead of the 14.0 CTAP link library in your linked list concatenation. Once that's been done and your linked list has been updated, simply run rim services. The parm statement you need, only one, is going to have a parm of reinit, CA1, pointing to your new 15.0 load library. Don't forget that both the version and the init statement have been changed to L0 Fox 0. Once rim has been run TMS init. Now, if you already have LU0 5200 applied, no changes at all. LU0 5200 removed 5 options. So if any of those 5 options are specified, you're going to get a WTO message indicating that it's an obsolete option, but TMS init will still run successfully. Prereqs for the CA1 15.0 for the encryption compression services. Pervasive encryption has been around for many years now. Most sites already have it and are using it, or they might be testing with it. If you do not know if pervasive encryption is active at your site, talk to your security administrative people. Attached here is a link to the Red Books that talks about pervasive encryption. If you don't know if pervasive encryption is active, excuse me, you might want to send a copy of this Red Book to your security admin people and ask them. Also, ZEDC is strongly recommended. ZEDC, of course, is the IBM compression routine. You can see whether or not ZEDC is enabled or not with the simple D space IQP command, display IQP. This will tell you whether or not ZEDC is enabled or not. It should be enabled. It's been available since the Z14s. Finally, zip is strongly recommended. Another simple command that will show you whether or not you have zips available or not is the display m equals core. D space m equals core. If it has an I under the status column, that means that it's a zip processor. So here I have 2 zip processors currently active. And zips are going to help reduce your CPU usage considerably, because almost all of the compression and encryption services are done in the zip coprocessor. Setup couldn't be easier. Is a new database, the tape encryption database, a primary and a mirror. And the mirror is just that, an exact mirror of the primary database. Now here you can see I've simplified the JCL to just define the primary and the mirror on a volume called TSO 764. I've put them both, never a good idea to put both of them on the same pack, but this is a test machine, and so I was able to do that. But you simply run an IDCAM's job to define your primary and your mirror database. Now there is a whole new set of control statements for the tape encryption feature of CA1. There's a new CTAP PARM separate from CTAP OPTN. The CTAP options still have all of the CA1 options in them. CTAP PARM is going to have the tape encryption control statements in them. BES PARMs is the primary member. It's similar to the TMO SYS member that in turn points to the other members. Note, the name itself is not going to be BES PARMs on your system. It's going to be in the form of XXXX BES1 or XXXX BES2, where XXXX is the SMF ID of the system where you're running. For example, XE90 BES1 means that the SMF ID of the system I'm running on is XE90, and BES1 is the name of the started task. And it points to members startup, dynamic, and keys. So if you are sharing your tape encryption database with 3 LPARs, and I'll just call it SYS A, B, and C, you would have a sys A BES1, a sys B BES1, and a sys C BES1. And they can all point to the same startup, dynamic, and keys member so that they have the same startup attributes, refreshable dynamic option attributes, and the same symmetric keys. But they could be different as well. Now the startup options simply lists your primary and your mirror database and whether or not you want to exploit the zip engines or not. That's a yes/no parameter. The dynamic options indicate whether or not you want to have a log stream active. The tape encryption feature will use the logger for diagnostic purposes, and the log detail level. Here I've got log stream set to none. I'm not doing any logging. So the log detail level, while I have it set to 3, is immaterial because I'm not logging anything. And finally, the percentage that runs on the zip. Again, the default is 100%, but you can have that less if you want to save your zips for other applications. The last member are the symmetric keys. With the tape encryption feature available now in CA1, we will take the DS key label, the dataset key label, specified in your JCL, your external security system, or your SMS data class, and we will actually go out and use that key label as a nickname. So it has to be defined here in the symmetric keys member of our PARM-lib. In this case, I've got 2 different keys, a key called Bill and a key called AES test. So my JCL might have DS key label equals AES test, or my SMS data class might say that the DS key label is Bill. Again, even though it's the DS key label, it's not the actual key label that we are going to be using. We're going to generate our own key label in the ICSF CKDS, the database that ICSF uses for their symmetric keys, the CKDS, but we will define it ourselves and we will reference it by the nickname. So in this case, the two nicknames are Bill and AES test. Now the algorithm is always going to be AES 256. The compression can either be S0 for the simple CPU usage that does simple duplicate character elimination, or compression can be set to S9, which is the ZEDC compression. If you are running on a system with a ZEDC processor, strongly recommend the compression be set to S9. ZEDC is wonderful compression. Now, as I said, these DS key labels are being used as a nickname. The actual key stored in the CKDS will be regenerated on a regular basis. That can be weekly, monthly, yearly, or manually. And how many generations are going to be pre-generated, you can also specify. In this case, I'm regenerating it on a manual basis, and I'm only going to generate 2 keys. That's it for the setup. Now, activation. The only trick is that when you're starting up the BES address space, the identifier must be BES1, BES2, BES3, all the way up to BES8. The member name itself is BES 1 through 8. If the member name is BES 1 through 8, then the identifier is not required. So an S space BES 1 works fine if the name of the started task is BES 1. But if the name of the started task is something called BES proc, then the start command would say S space BES proc dot BES 1. So that BES 1 becomes the identifier. Now, the only reason you would have both a BES 1 and a BES 2 is if you are afraid there might be an append, in which case new tape files will not be encrypted and files previously encrypted will not be read. So if BES 1 and BES 2 are both active and BES 1 appends, BES 2 will pick up and perform any requested compression and decompression services. Now, the first time that you start up this BES 1 or BES 2 proc, you're going to get a BES 1KM597W message, which will say what is the password you want to use for the database. It's important. It's critical, in fact. It should be saved in a safe location. It is required to read previously encrypted files. After you've entered the password for the database, you will be asked to confirm the passphrase. Don't forget to write this passphrase down, because if you bring up BES on the same system, you will not be required to re-enter the passphrase. However, if you come up on a disaster recovery system, if you come up on a different CPU because of a CPU upgrade, you will need to know what that passphrase was. Lots of commands. The easiest way to see a list of all the commands is to issue BES1 space help. And the help will list all of the other commands you can do. You can do displays, you can take a dump, you can refresh options, you can refresh the symmetric keys, you can regenerate a key, you can reload modules such as TEP. Here's an example of the display parameter list short. I enter BES1 space D space P, display parm. Commands accepted, and it lists my parameters. It's as simple as that. Now, if you want to change the passphrase on the database, I would recommend doing it on a reasonably regular basis. Is that once a quarter, twice a year, once a year? I'll leave that, of course, to you, but I do recommend you change it on a regular basis. To change the password, you issue the command bez1 space reload equals passphrase. It'll ask you to enter the current passphrase, and then it asks you to enter the new passphrase and confirm the new passphrase. And there's a nice little bez1 KM590I message reminding you, do not forget this passphrase. You'll need it at a DR location or if you do a CPU upgrade. So the only best practice I can give you is to change the passphrase on a regular basis so that you remember what it is and you know what it is. There is no backdoor. If that database is lost, all of your encrypted tapes are lost with it. Debugging utilities, the main one, of course, is the health checks. There are lots of new tape encryption health checks that are introduced when you start up the Bez address space. And how can you make sure that tapes are actually being encrypted? The easiest way is to run a tape map. You can use the copycat tape map that came with the product. There should be a vol1, the header 1 and header 2, and then a user header label 1, 2, 3, and 4, followed by data, followed by the end of file marks, including user trailer labels 1, 2, 3, and 4. Another option is to run an IDCAMS print with SUL as the label type and the DCB specified as record format undefined LRECL 32760. Now in this example, I'm printing off the first 10 records of a volume whose file name is russell.test.tmc.copy. And that data that's going to be printed off is going to be the compressed and encrypted data that's on the tape, because that tape was created with tape encryption. Thank you, and I hope that you will be able to successfully implement the pervasive encryption feature of CA1 and start to encrypt your tape files. Doesn't matter if you encrypt them to physical tape, virtual tape, CAV tape tapes. Doesn't matter where you're encrypting them to. The fact that you are encrypting the tape data at rest is the most important thing. Thank you.